what you have for us today.
All right. Thank you very much. Thank you a lot. Thanks a lot, Koha. All right, let's get to business. Yeah, without any further ado. Okay, so I will share my screen so we can quickly start. All right, can you see my screen?
Oh yes, I can.
All right. Okay, let me just quickly put this guy out. Okay. All right, everyone. So just to confirm again, you can see my slides, right? My presentation. Hello.
Yeah, I can see your presentation.
All right.
Yes, I can see you too.
All right, great. Okay. Yeah. So today we'll be going through like the title of the session is getting started with Arbitrum, a developer's guide. So I'm going to like walk you through the whole Arbitrum ecosystem. You get to understand what Arbitrum is all about and what they are trying to do, the problem they are trying to solve. And we are going to look at the versions and tools or suits of Arbitrum. And also we'll be talking about one of the Arbitrum suit, which is Stylo, because one of the things you'll be doing in this hackathon is to build on Stylo, and we'll get to understand what Stylo is all about and how you can get started with building on Stylo and all. So yeah, that's basically it. My name is Casweeney Ojukwu. I'm coding cars on Twitter and Telegram. So yeah, okay. So getting started, I'm sure a lot of you must have been hearing about Arbitrum. So for this workshop, I believe everybody here is a blockchain developer. So I wouldn't need to go through the beginning of talking about what is blockchain and blocks and nodes and all of that. So I believe everybody here is a blockchain developer. So I'll just go into like talking about Arbitrum and why Arbitrum and all of that. So yeah, you must have heard about the fact that Ethereum is having a problem. And when we talk about Ethereum is having a problem, we say Ethereum is having the problem of scalability and all. And because of that problem, many ideas, many protocols have popped up to try to solve this Ethereum's problem. And we never knew Ethereum had a problem until the DeFi bubble, the period where Pancake Swap, Uniswap became a thing, where everybody was trading crypto on Pancake Swap and Uniswap, and people were buying bought ABH, NFT, you know, crypto pumps and all of that. Because of the large influx of transactions that hit the Ethereum blockchain, that was when the problem of Ethereum became known to a lot of persons, because the transactions became very slow and gas fees skyrocketed and went very high and all. So that gave rise to different guys trying to solve the Ethereum scalability issue. And in the course of solving this Ethereum scalability issue, there were two approaches to which these problems were attacked. One of the approach is using what we call optimistic rollup, and the other approach is using what we call ZK rollup. So Arbitrum is one of the scaling solutions that is solving Ethereum scalability issue. So from what we have here in the document, you see Arbitrum is a technology suite that is designed to scale Ethereum. So with Arbitrum chains, you can do everything you do on Ethereum, like using Web3 applications, deploying smart contracts, and all. But the difference between Arbitrum and Ethereum is that on Arbitrum, transactions are cheaper and faster. Like I said, because of the high influx of transaction became very slow, and gas fee went very high on Ethereum. So, but on Arbitrum, you can do everything you do on Ethereum on Arbitrum, but it's faster on Arbitrum and it's cheaper on Arbitrum. So this is the solution, the scalability solution that Arbitrum is providing to Ethereum and all. So Arbitrum is a layer 2 protocol that uses optimistic rollup to improve scalability, speed and cost efficiency of the Ethereum blockchain while inheriting the Ethereum security. So now, for those who might be hearing what layer 2 is for the first time, layer 2 blockchains are blockchains that are built on top of an existing layer 1 blockchain. So layer 1 blockchains are blockchains that are standing on their own. For example, Bitcoin blockchain is a layer 1 blockchain, Ethereum is a layer 1 blockchain, and many others. But for now, I'll just stick with those two because that's the most popular layer 1 blockchain we know. So because Ethereum is having a scalability issue, and Arbitrum is trying to solve this problem. So you might ask, why didn't Arbitrum build their own protocol and all of that? So there's something called a blockchain trilemma. I just hope I'm not spitting out a lot of technical jargon that is confusing a lot of persons, but there'll be room for questions though. So I think it would be cool to write your questions down. So when we get to the time for question, you can fire me with all the questions you have. So there's something called blockchain trilemma, and blockchain trilemma states that no blockchain can solve the three main concerns of the blockchain ecosystem. And the three main concerns of the blockchain ecosystem: one is scalability, the second one is decentralization, and the third one is security. So this means if a blockchain is decentralized and secure, that blockchain cannot be scalable. And if a blockchain is scalable, like if a layer, for instance, we have other blockchains, layer 1 blockchains that are scalable, like they are fast, they have low gas cost, but their security is not there. They have a very porous security. I won't mention their names, but now blockchain trilemma is saying if a blockchain is scalable, that blockchain it might not be secure, or the blockchain might not be decentralized. So no particular blockchain can have all these three features in them as a whole. So now what layer 2 blockchain do is, instead of them trying to solve this security and decentralization issue, they leave that for Ethereum. They focus on scalability and they build upon Ethereum's decentralization and security. That is what layer 2 protocols do. So Arbitrum is one of these layer 2 protocols that inherit or is sitting on Ethereum's decentralization and Ethereum security. So I don't know if that makes sense, but I believe it does. So while they are sitting on Ethereum decentralization and security, they are solving the scalability issue and all. So we are going to see what optimistic rollup means. I know some of you might have that question. So what then is optimistic rollup? So let's move to the next slide. So features of optimistic rollup. When we say something is optimistic, that means, when we say someone is optimistic, let me just read what's here. Arbitrum processes transactions off-chain outside Ethereum in a rollup and post minimal data block to Ethereum mainnet. This reduces the load on Ethereum and enables high throughput. So what this means is, for instance, let's say on Ethereum, we are supposed to handle 10,000 transactions on Ethereum. And if you're handling 10,000 transactions on Ethereum, Ethereum will have to process each of these transactions one after the other. And imagine 10,000 transactions coming all at once. It's going to be a load on Ethereum and all of that. So what Arbitrum does is, Arbitrum is going to take all these transactions, let's say Arbitrum takes like 5,000 transactions, and it's going to batch them together. Like it's going to batch them together to roll them up into one block of data. And what Arbitrum will send to Ethereum is just one block of data that has these 5,000 transactions. You now see that by so doing, it has reduced the load or the time it would have taken Ethereum to process 5,000 transactions into one transaction. So what Arbitrum does is it rolls up these transactions into one block and submits the data to Ethereum. So that data it submits to Ethereum contains 5,000 transactions, but it's submitting it to Ethereum as just one transaction, therefore minimizing the load or the time it would have taken Ethereum to process the 5,000 transactions. So now, if Ethereum was supposed to process 10,000 transactions, and Arbitrum is badging 5,000 transactions for each transaction, that means Arbitrum will be sending just 2 transactions to Ethereum for 10,000 transactions that Ethereum would have handled individually. So you see that with this, it has reduced the time and load Ethereum would have taken to process each of these transactions one after the other. So that is what is called a roll-up. A roll-up is the process of like rolling up transactions, badging them into a single data and submitting it to your layer 1 chain. So that is what roll-up is. Then let's look at when we say optimistic roll-up. So in the goal to solve Ethereum's problem, there are 2 types of approach. So one is ZK rollup and the other one is optimistic rollup. So the ZK rollup is a zero knowledge proof, but that's not the purpose of this class for today. So, but for Arbitrum uses the other one, which is the optimistic rollup. So optimistic here refers to the assumption that all transactions are valid unless being proven otherwise, which means when Arbitrum submits transaction to Ethereum, it is assumed that these transactions are valid. You understand? So you know the blockchain statement, don't trust, verify. Yeah, but Arbitrum are already trusting. So once they badge this transaction, they post it to Ethereum, that transaction is assumed to be valid. Now, but there's something that happens on the Arbitrum ecosystem. When these transactions are posted, there's something called a challenge period. That challenge period used to be 7 days. The challenge period is like a period that is kept for watchers. Watchers are people that will be looking at these transactions to find anyone that has fault. So watchers will be looking at this transaction, and if they figure out that any of this transaction is fraudulent, they are going to challenge that transaction, and they are going to submit what is called a fraud proof. That fraud proof is like a proof to tell that this transaction is fraudulent. And if they submit that fraud proof and it is seen that this transaction is fraudulent, that transaction will be reverted, and the validator that submitted that transaction will be slashed. So for the guys that are blockchain developers here already, so I just hope you guys are following, because one of my goal to explain things like this is to ensure that I'm carrying everybody along. So, and yeah, when we say validators are slashed, if you're a blockchain developer or you're being in the ecosystem, you know that Ethereum currently runs on proof of stake. And proof of stake requires that before you become a validator on the Ethereum blockchain, you have to stake a particular amount of Ether. And that Ether you're staking is the criteria for you to be selected as a validator. Now, and it's also used for crypto economics. So the reason why you stake is so that you don't carry out any fraudulent action, because when you carry out any fraudulent action and it is figured, that Ether you stake will be slashed. So that is what this slashing here means. So if you post a fraudulent transaction and it is challenged and proving that that transaction is fraudulent, you're going to be slashed, right? All right. So this is just like a brief overview of how the Arbitrum blockchain, layer 2 blockchain handles things. So let me do a quick rundown. So Arbitrum processes transactions off-chain outside of Ethereum. They roll this transaction up into a single data and they post it to the Ethereum blockchain. And when they post it to the Ethereum blockchain, Arbitrum by default assumes that these transactions are valid. And they now give a window period of 7 days. I think it has been reduced to 24 hours, but they give a window period for watchers to watch through these transactions and challenge anyone that they think is a fraudulent transaction. And once they challenge it, they provide what is called a fraud proof to prove that this transaction is fraudulent. And if that transaction that they challenge is actually found to be fraudulent, because it's still within that window period, that challenge period, is going to be reverted, and the validator that posted that transaction will be slashed. All right. So that is that about Arbitrum. Let's move to the next guy. So let's look at the benefits of Arbitrum. So one of the benefits of Arbitrum, like for devs that will be building on Arbitrum, one of the benefits of Arbitrum is that you're going to have fast transactions because it takes a while for transactions to get validated and added to the block on Ethereum. But on Arbitrum, it's not like that. Transactions on Arbitrum are fast, cost efficiency. So I remember some time ago where I wanted to send out 10 USDT from my Trust wallet, and I was asked to pay $50 as gas fee. Yes, imagine sending 10 USDT, $10, and you're paying $50 as gas fee. I've experienced that in the Ethereum blockchain, but on the Arbitrum ecosystem, it's not like that, because Arbitrum is already solving that problem, that scalability issue of Ethereum. So Arbitrum is cost efficient. Then interoperability with Ethereum. So just like Arbitrum is built on Ethereum, and on Arbitrum is EVM compatible, which means you can still write Solidity, the same Solidity you write, the same smart contract you write with Solidity that you deploy on Ethereum, you can still do that on Arbitrum without needing to learn a new programming language. And Arbitrum is also developer friendly in the sense that Solidity, EVM, they are all EVM. Arbitrum is an EVM compatible chain, so you can learn Solidity and you can use it on both Ethereum and Arbitrum. So that's why it's developer friendly. So Arbitrum versions and suites. So this is the reason why we are going through this route is because the main purpose of this workshop is for you to build on Stylo. So we can't just jump into Stylos without like taking you through some of the chains, the protocols, the services that Arbitrum have. So it's like a general rundown for you to understand the Arbitrum ecosystem. So Arbitrum has multiple chains, protocols. So before I proceed, let me be sure. Hope I'm not going too fast. The guys, can someone just unmute and let me know? Hope I'm not going too fast.
Yeah, I'm catching up.
If you're catching up, that means I'm running.
No, I'm not running. It's okay.
Okay,
No,
all right. All right, great. So Arbitrum has multiple chains, protocols, and services that serve different purposes. So we are going to go through one of them. So with this, you can comfortably hit your chest and say that you understand the Arbitrum ecosystem and you know everything about Arbitrum. So we have Arbitrum 1. So when you hear about Arbitrum Layer 2 scaling solution, the main guy that is solving that problem is the Arbitrum 1. This is the primary L2 chain for general purpose Ethereum scaling, focusing on decentralized finance and decentralized application ecosystem. So Arbitrum 1 uses the optimistic rollup to achieve this. We have explained optimistic rollup. So Arbitrum 1. So once you hear that Arbitrum is a layer 2 scaling solution, the first thing that comes to your mind is Arbitrum 1. It is the guy that is at the center of that layer 2 scaling solution when you're building smart contracts for DeFi, like your swap and all of that, your lending protocol. It is on Arbitrum 1. So Arbitrum 1 is the main guide for the general purpose Ethereum scaling and all. Then we have Arbitrum Nova. Arbitrum Nova is a version of Arbitrum that is optimized for gaming and social applications. So you believe me that when it comes to gaming, it requires a higher level of scaling because games are like the complexity of games. Imagine you playing a game and for every move you make in that game, you're paying gas fee and all of that. So you know that would be a tedious game to play. So Arbitrum Nova is mainly focused on gaming and social applications that require high throughput but lower cost. High throughput means high efficiency and all, so but lower cost. So it is developed by the same team behind the Arbitrum 1. Remember, Arbitrum 1 is the guy that uses the optimistic rollup stuff. So Arbitrum Nova is also built by the same team that built Arbitrum 1. But Arbitrum Nova is not using optimistic rollup. It is using a technology called AnyTrust. AnyTrust is like a different technology that Arbitrum Nova is used. This is like the technology they use to build a more efficient protocol that can house games and social applications. All right, so let's proceed. So we have the Arbitrum Orbit. So Arbitrum Orbit is a framework. Imagine you like you can build your own blockchain from scratch. Like you can build your own blockchain without, I know most of when you hear blockchain developers, what comes to mind a lot of time is decentralized application developers, people that write smart contracts and build a front end that interacts with the smart contract. That's the general idea of blockchain developers. But imagine a blockchain developer that can build blockchain. So that is the future of Arbitrum Orbit. Arbitrum Orbit is a framework that allows developers to deploy their own layer 3 chain. So the reason why it's called layer 3 chain is because layer 3 is built on top of layer 2. So this blockchain you're building, they are built on top of Arbitrum, and Arbitrum is a layer 2. So that is why they are called layer 3. So the Arbitrum Orbit is a framework that enables you to build your own blockchain on top of Arbitrum L2. So this offers more customization and scaling potential. And one thing about blockchain built with Arbitrum Orbit is that they interact with other blockchains that are built with Arbitrum Orbit. For instance, let's say I build my own blockchain and someone from the core build their own blockchain using the Arbitrum Orbit. My blockchain can easily interact with yours because it is built on the same ecosystem and all. So that's what the Arbitrum Orbit does. Then we have Arbitrum Nitro. So Arbitrum Nitro is a major upgrade to the Arbitrum layer 2 scaling solution. So Arbitrum Nitro is like, Arbitrum Nitro is not a framework and it's not a blockchain. It is like the engine. So for Ethereum, we have the Ethereum virtual machine. For Arbitrum, the engine that handles all this optimistic rollup, the whole all the things we have talked about, the engine is the Arbitrum Nitro. It is where all these complexities, all the complexities, the things you don't see, the whole logic, it is on the Arbitrum Nitro. That is the engine that powers the whole of the Arbitrum ecosystem. So Arbitrum Nitro is like the upgrade to the Arbitrum layer 2 scaling solution. So it is a supercharged engine at the center of the Arbitrum protocol. Now we have Arbitrum, we have Stylo. So the main focus of this call is the Stylo. And we are going to see what makes Stylo amazing and powerful. So Stylus is not like a version of Arbitrum. It is rather a technology upgrade to the Arbitrum Nitro stack. Remember that Arbitrum Nitro is the engine that powers the whole of the Arbitrum ecosystem. So Arbitrum Orbit, Arbitrum One, Arbitrum Nova, they are all running on the Nitro engine and all. So Stylus is another upgrade of the Arbitrum Nitro. So there's something that was added to the Arbitrum engine that made it better. And that new engine is called the Stylus and all. So instead of calling Stylus a version of Arbitrum, it is rather a technology upgrade to the existing Arbitrum Nitro stack, which powers Arbitrum chains like Arbitrum One, Arbitrum Nova, and Arbitrum Orbit. You see this now. It powers the Arbitrum chains, and the Arbitrum chains involves the Arbitrum One, the Arbitrum Nova, and the Arbitrum Orbit. That's the framework to build on other blockchains on Arbitrum. So let's look at what Stylus does. So you know, when you hear that a blockchain is EVM compatible, it means that the blockchain is using the same virtual machine, just like the Ethereum virtual machine. So that means it's EVM compatible. And a lot of Solidity developers are happy because we don't need to learn a new programming language. With Solidity, I can build on Ethereum, I can build on Arbitrum, I can build on Optimism, I can build on Binance Chain, I can build on all EVM compatible chains. But now, all these other chains are limited because if I am a Rust developer or I'm a C++ developer, for me to build on maybe Optimism or Binance Chain or Polygon and all of that, I need to come back to learn Solidity. But now, this Arbitrum Stylus, what Stylus did is, they made it possible that you can write smart contracts with Rust, C, and C++, and this smart contract will still run perfectly on Arbitrum. They can run the same way Solidity runs on EVM and all. So you don't need to start going to learn Solidity and all. So what the Stylus upgrade did is, the Stylus upgrade now made it possible that the Arbitrum core is running two virtual machines, the EVM and the WebAssembly virtual machine. So the EVM, when you write smart contract with Solidity, is going to run on the EVM part of the Arbitrum Stylus. And when you write smart contract with Rust, C, or C++, it's going to run on the WebAssembly part of Arbitrum Stylus. So it's like, they call it, I've forgotten, it's like co-VM or something, like two virtual machines working simultaneously hand in hand. Depending on the programming language you use in building, it's going to handle it efficiently. So we are going to see how this works in the next slide. So what is Stylus? So if you look at this diagram, you see what is here. Stylus gives you multi-VM. So the one on the left-hand side, this is EVM. Solidity compiles down to EVM bytecode and goes to the Arbitrum Nitro. You see that Arbitrum Nitro is where the EVM is. Like I said, the Arbitrum Nitro is like the core of the whole Arbitrum ecosystem. So the bytecode is pushed to the Arbitrum Nitro and is being processed by the EVM, that's the Ethereum virtual machine on the Arbitrum Nitro. And you see your smart contract and all of that. Now, this is what Stylus does. The one on the right is the upgrade, that is the Stylus. This is a multi-VM. You see you see Solidity to EVM bytecode, and it enters the Arbitrum Nitro. There's EVM there ready to handle it. If you also write your contract in Rust, C, or C++, it compiles down to WASM. WASM means WebAssembly. And this WebAssembly hits the Arbitrum Nitro, and the WebAssembly virtual machine handles it, and everything works perfectly well. So the current upgrade of the Arbitrum core is the Stylus, which can handle both Solidity, Rust, C, and C++ code base. But for the purpose of this workshop, because Rust learning curve is kind of steep, and trying to like build with Rust on this workshop will be like pouring stone on water. So we are going to stick to solidity, which is common among blockchain developers. So you'll be able to build a good product or something worthwhile by before Saturday, which will be like the mini hackathon and all. So let's proceed. Now we have building on stylus. Yeah, building on stylus. So we are going to see how we can build on stylus. So moving over, we have the stylus testnet information. So with this, you can add the Arbitrum. So stylus is currently on the Sequoia testnet. With this, you can add the network to your MetaMask wallet. So because blockchain developers in the house, you know what this is, but I'm going to explain it for other persons. So for you to deploy your smart contract to a particular chain, you need a wallet. And if you want to deploy to a specific chain, you have to switch to that chain. And for you to add that chain to your MetaMask wallet, you need all this information. You need all of this and yeah, and all of that. So maybe in the question section, if there's anybody that doesn't know how to add this, we might do a little demo for that. So we move over to getting faucet. So to get faucet oh shit, I didn't update this, sorry. Okay, I think I'm just going to change it. But before that, I'll just pick it up from the Arbitrum documentation. So to get faucet on the Arbitrum stylus, you need to head to, let me do this quickly. Give me a moment. Yep. All right. Yeah. Okay, so I'm going to bring down this stuff over here so you can see this. So this is the Arbitrum documentation. So if we hit down to stylus, we're going to see testnet. And yeah, this is exactly what I was looking for. So to get faucet, you can get your faucet from QuickNode, you can get it from Alchemy, and you can get it from this other guy. But I got mine from Alchemy. And for you to get your faucet from Alchemy, it requires that you have up to like 0.001 Ether on mainnet. So I do have that. So I was able to get my faucet from this guy. But when we start like building, I'm going to walk you through this. But for now, let me just finish the slide. All right. Okay. So let me take this out. All right. Okay. So moving to the next guy. More about stylus. So there are other tools that the stylus Arbitrum made available on top of stylus. So we have the stylus Rust SDK. The stylus SDK enables smart contract developers to write programs for Arbitrum chains in the Rust programming language. Stylus programs are compiled to WebAssembly and can be developed and can be deployed on chain to execute alongside Solidity smart contracts. So we have gas and ink. These are pricing primitives that are used to determine the cost of handling specific opcodes on stylus. So opcodes is a short form of operation codes. I don't know if I should explain this, but let me just do justice to it. So Solidity is the hello?
Oh, all right. Thanks, Tammy.
Okay. All right. So opcode means operation code. So when you write your smart contract, for instance, so let's say you write a Solidity smart contract, it compiles down to bytecode. When you're deploying it, that bytecode is what is pushed to the Ethereum virtual machine. But when you perform an action, for instance, when you click a button or you call a function, the Ethereum virtual machine has a stipulated operational flow of which is going to handle that instruction you're giving to it. And the way it handles that instruction is in what we call opcodes and all. So I can start telling you things like push one, push two, mstore, and all of that, but it's going to confuse you the more. But for now, let's keep it high level so you don't get more confused. But just understand that opcodes is like the operation codes, like the operation steps in which the EVM processes instructions and all. So now we just talked about the EVM. So on the other hand, same opcodes on WebAssembly is WebAssembly VM is the same way the WebAssembly virtual machine is going to handle operations that is being asked of it and all. So this gap and ink is like a pricing primitive that are used to determine the cost of each opcodes on the virtual machine. So I can give you example, for instance, in Solidity, whenever you call another function, like you make a call to another function inside a particular function, the opcode that handles that is called jumpy. And that jumpy opcode costs about, I think, 25,000 gas. I can't remember, I'm not sure, but it has a particular amount of gas it costs for that particular opcode. So this gas and ink is what enables you to determine the cost of each of these opcodes. I hope I'm able to do justice to that. Yeah. All right, so we move to the next one, which is called CLI tool. So CLI stands for Command Line Interface and CLI tools. So the CLI tool here in question is called Cargo Stylus. A CLI tool provided for Stylus, specifically this Cargo Stylus tool, designed to help developers manage, compile, and optimize their Stylus contracts efficiently. So a CLI tool is, all those tools you can use to, for instance, those of you that are familiar with NPM, you do NPM install, it's going to install a particular stuff and all of that. So NPM is a node package manager, and it's also a CLI tool because it's through your command line interface that will make use of NPM to do specific instructions or to give it specific commands and all. So Cargo Stylus is similar to NPM, but it's specifically tied to the Stylus framework or Stylus engine and stuff like that. And whenever you hear cargo is tied to Rust. Yeah, because the Rust package manager is called Cargo. So Cargo Stylus is like the Rust package manager for Stylus. Yeah, I hope that's clear enough. All right, we've come to the moment of truth. This is where we are going to write a simple smart contract. And this simple smart contract, we are going to write it and we are going to deploy it on the Arbitrum blockchain, Arbitrum Sepolia. And deploying it on Arbitrum Sepolia, we are actually deploying it on Stylus because the current core of Arbitrum has support for both EVM and the WebAssembly VM. So if we deploy Solidity smart contract, it's still going to hit Stylus. If we write it on Rust, it's still going to hit there and all of that. So let's get to business. I don't know, just to confirm, should I just explain a particular contract I have written, or should I write the contract from scratch? Koha, I don't know if you're there, just help me, because writing it from scratch might take a little more time. So I don't know if I should just like walk through a contract I've written, then show how to deploy it on Arbitrum, if that makes sense. Hello?
The walkthrough will be good.
I think a walkthrough would be better.
Okay, like not writing it from scratch, right?
Yes. Since it's
Okay.
written, we just this segment is this. No, walkthrough is better. I think it's better.
All right. Okay, let's get to that. I have a couple of small smart contracts here. Yeah, let's just look at this. So this is a small smart contract I was using to like teach some students at Web3 Bridge how to write a smart contract where you can save Ether into a smart contract and all. So you can deposit Ether, you can withdraw the Ether, you can get the balance and all of that. So this is a contract. It's written with Solidity and all. So this is the contract, Save Ether contract. We have our license identifier and we are using MIT. We have our Pragma Solidity statement. This specifies the version, you specify the compiler version you want to be used when compiling the smart contract. So we are using 0.8.21. And here is where we are declaring our contract and we named it Save Ether. And also we want to be able to track who owns this contract. And ownership here is like the person that deployed the smart contract. So we created an address called owner. I can put public here so that we can easily call this and see the address of the owner. And we have a mapping. This mapping, so whenever you see mapping in a smart contract, it means you're tracking something. So we want to be able to track the balances of the user that have deposited. And mapping goes, it's like a key value pair. So it has a key which is unique to a particular individual, which is the address, and it returns a UA256, which is like the amount the user deposited in the contract. And we have a constructor here. The constructor is a function that runs .1, and that is at contract deployment time. When you're deploying your contract for the first time, that's when this constructor function is called. And here we are setting the owner to msg.sender. In Solid, msg.sender is a global variable. And in Solidity, whenever you call msg.sender, msg.sender refers to the person that is currently making a call to that contract at that time. So if I'm deploying this contract, I am making a contract deployment call, and the msg.sender at that time is the wallet address, the account I am using to deploy this contract is the msg.sender. So automatically, it sets my address to the owner here inside this constructor. Then we have events. So events is a way of logging activities in using your Solidity code. So let's say you perform a particular action and you can emit event to log it on the blockchain or the EVM that, okay, this thing was successful. And the front end guys can actually use this event to give user specific messages on their front end display. For instance, when you deposit, using the event, they can display something like a success message and all of that based on the event. And yeah, so we have the deposit function. The deposit function is payable. So whenever you want to like use a particular function to deposit Ether, Ether is the native token of the Ethereum blockchain. And so I mentioned Ethereum blockchain. So if you're deploying on a chain other than Ethereum, this payable, for instance, if we're using Arbitrum still uses Ether for their gas fee, so it will still be Ether. Yeah. So whenever you want to like deposit funds into a smart contract using a function, you have to make that function payable, which means this function can accept Ether. So here we are using a require statement to perform some particular check. So here, right here, we are doing what we call sanity check. Sanity check is to ensure that the person that is calling this function is not an address zero. So, and someone might ask, but an address zero is not an EOA. So how then can an address zero make a call? But there's a way you can use address zero to make a call. But that's when we go into security and expectations of smart contracts. That's out of the scope of this workshop. Now, msg.value. So whenever you make a function to be payable, it is required that you're passing a value of Ether you want to deposit in that contract. So msg.value is a global variable used to listing or check the amount of Ether you're depositing or you're passing when calling this function. And we are requiring that the value is greater than 0. Else, we are going to throw a message that you cannot deposit 0 value. Then here now, using the mapping, because our mapping is balances, using the mapping, the key here is msg.sender, because at the instance of calling this function, the person that is calling this function, the address is the msg.sender. So what we do here now, we are incrementing the value to the balance of the person using the value the person passed, the value of ether the person passed. And once we do that, we emit an event say deposit successful. Then here we have a withdraw function. This withdraw function is used to withdraw the amount the user has deposited into a contract. So we have a require statement that also does a sanity check to check that the person calling this is not address 0. We also have a require statement that ensures that, so this require statement is just to help users not to waste gas. So imagine you want to withdraw and you're passing 0. What are you withdrawing? You just pay gas fee for nothing. So with this require statement, it's going to throw an error if the amount value you passed in here is 0. Then it also requires that the balance the person have in this contract is greater than the amount, because you cannot withdraw what you don't have, else it will tell you insufficient funds. Then here, before we initiate the transfer to the user, we first deduct the balance. Why we are doing this is to avoid reentrance fee. Reentrance fee is the process whereby you call this function over and over again until you drain the whole money in this contract because of one silly mistake. But that's just like a high level of what reentrance is. If I want to go deep into reentrance, we might take another 30 minutes. So this is where we are performing the call. We are using the call function to send the amount the person wants to withdraw to the user. So we are saying msg.standard.call value here is a parameter, and we are passing in the argument for that value, which is the amount the person wants to withdraw. And once we do this, we now do another require statement. So this guy here returns, this is like we are doing the structuring here. This returns a Boolean and data. So we are getting the Boolean value here, which returns true if this transaction was successful. Who is writing on my screen? It will be Y. So we use this this returns bool and data. So if this is true, it means this transaction here was successful. So require that this is actually true, else will throw an error message that the withdrawal process failed. And then we have this to return the contract balance. So all the money users have deposited in this contract is going to return the balance. And we have this here, my balance. This is for user. If you want to check the amount of deposited into this contract, you call this my balance. So this here was like a function requested by one of the Web3 students while teaching that what if there's a way whereby a user that has funds inside the contract can transfer the money to another user rather than to themselves. That is why we added this function. So with this, you can transfer the funds you have in your contract to another user entirely and all. So this is just a short, quick rundown of the contract we have here. And now we want to actually deploy this contract on Arbitrum. So first things first, I'm going to go to my MetaMask and I'm going to click on settings. So I want to, what's that? This is just this test tokens now. If you want to dash me money, please send me money. So this is settings. We go to networks and we go to click on add network. So when you do this, you're going to see this page. You can click on add network manually, but let me just click on network. I'll click. I already have the Arbitrum Sepolia here, so I'll click on it. Now, if you look at this, you see this is Arbitrum Sepolia. Let's quickly look at what we have here. So this is it, Arbitrum Sepolia. This is what we have here. This is Arbitrum Sepolia. So this is also the RPC URL, which is the same thing we have here in this place. So this is 421614, and this is 421614. This is the Explorer, and this is the Explorer, and the currency symbol is Ether, and which is what they didn't really specify this, but Arbitrum uses Ether. Let me see, yeah, Arbitrum uses Ether, so that's why we use Ether here. So once you've added this network and you want to deploy on Arbitrum chain, so sorry, you see compromise here. This is my the wallet I use to teach people. Like in the process of teaching and all of that, I've exposed my private key 1 or 2 times. So I don't use this wallet to do anything other than to teach. In case maybe I expose the private key, there's nothing there, you know. So that's why you see the compromise there. So now if once you've done this, for you that will be doing it for the first time, once you add this, you just click on. So for your own case, you click on add new network, you click add network manually, you fill all these stuffs here and you click on the save. Once you save it, you now have Arbitrum network, which is also the Stylus, which contains the Stylus engine. Now with this, sorry, let me move this over here. So with this, we have our Arbitrum guy, and sorry, go out of here. Now, if I click on this guy, you see I have all my networks here. These are all my network, and I'm selecting the Arbitrum Sepolia. So once I'm on Arbitrum Sepolia, I'm going to now, let me reload this page so that I can connect my wallet. But before that, let me disconnect so everything works clean. So I'm going to disconnect this account from here. All right, it's disconnected. I'm going to reload this page now sharply. Okay, we have it up. Load. Yeah. So the name of the contract is Save Ether. So this is it. And with this, you see this green check here. It shows that the contract has successfully compiled. Mine is on auto compile. For you, if this is the first time you're using Remix, yours might not be on auto compile. You have to click the compile guide here to compile it. But I always keep mine on auto compile. So I'm going to click on deploy and run transaction, this button here, deploy and run transaction. Once I click on it, you can see that my contract is here, Save Ether and all. So for me to deploy to Arbitrum chain, I'll click here, I'll click on injected provider MetaMask. So it's going to connect to MetaMask, and since MetaMask is on Arbitrum network, automatically it's connected to Arbitrum network. So I'll click on this. MetaMask comes up, I select my account 1, confirm it, and it's connected. So you can see that now, custom 421614, which is the same with this 421614. That's the chain we are connected to. So if I deploy my contract now, all I just need to do is click on deploy. MetaMask will come up, wait for it, and I'll click confirm and wait for it. So yeah, and we have deployed this. We have deployed this guy now. This contract is now on Arbitrum. So this is it. With this guy, we can interact with this contract. We can deposit it, transfer, and all. So for us to check if this is actually deployed, let me just go to MetaMask and click on this guy. So this is it. I'll click on this guy, view on Explorer. So you see that it's sepolia.arbiscan.io. It's going to open that contract now on Arbitrum Scan, and you see that the contract is on Arbitrum. Why is it taking a while? All right, we have it. So this is it. This is our contract. This is our where is the contract address? Transaction hash. Where is the this is the no. Okay, so this is the contract address 32FA, ends with 32FA. Let's confirm it over here. It ends with, look at it here, 32FA. So, and with this, we have successfully deployed our smart contract on Arbitrum, which is also on the Arbitrum Stylus engine and all. So, going back to our slide, where is that slide again? Yeah. Going back to our slide, let's see what we have next. Slideshow. And we have the end. So ask your questions. Hope that was not too fast.
In my opinion, no. I think that was sizable.
All right. Okay.
All right. Thank you so much, Cass. That's it. I guess it's question time, yeah?
Yes. So yeah.
Yes, it is. Yes, we are recording. Caleb, we are recording the session, and right after this, we should have it on YouTube. All right, Monday, you have the floor, please.
Okay. Hi everyone. Okay, it's
Hey,
Essay. Monday is my surname.
sorry.
I have a question. You said something concerning account zero. You said it was a security, something about security. Can you explain further on that?
Oh,
About
okay.
account zero sending the transaction.
All right. So when you're writing smart contracts, there's what we call externally owned accounts and contract accounts. Externally owned accounts are those accounts that have private keys, like your wallet. Those address, those your wallet, they are all externally owned accounts, shortly called EOAs. And we have contract accounts. Contract accounts are your smart contract. When you deploy a smart contract, an address is generated. So that kind of address, that kind of account is a contract account. Now, transactions on the blockchain, on the Ethereum blockchain, can only be initiated by an EOA, by an externally owned account, because they have private key. They are the only accounts that can initiate transactions. So smart contract can call functions in other smart contracts, but the initiator, the TX.origin, all transactions begins with an EOA. So you might call a function in a smart contract that calls another function, but the starting point of that process is an EOA. Now, when we do sanity check, it's called sanity check in security. When we do sanity check, you and I know that address zero is like a zero address that doesn't have private key, which means it cannot initiate a transaction. But why then are we ensuring that the MSG.sender is not address zero if we know that address zero cannot initiate transaction? Now, there's a particular kind of attack that can be done using address zero. Now, if you're calling, if I initiate a low-level call inside a constructor of a contract, I initiate a low-level call inside the constructor of a contract to call a function in another contract. Now, at contract deployment time, that is when, because that call is happening inside the constructor and it's going to call another smart contract, a function in another smart contract. At contract deployment time, when the contract has not been deployed and the constructor is performing a call to another smart contract, at that point in time, the MSG.sender is address zero. And if you didn't do that kind of security check in your smart contract, maybe address zero could be able to move funds from your contract depending on the vulnerability that exists in your contract. So we call it sanity check, which means this is not necessarily needed, but will it harm you to do it? No, just add it. Does that make sense?
Okay, so it's more like a check, because I think there are sometimes when there are some vulnerabilities in your contract. Some people deliberately use their contracts to go and exploit your contract. But I think I get.
Yes, that's it. Yeah.
Thank you very much.
You're welcome.
All right. Any other question from somebody else, or you have something to add that you think is important to share?
Yeah, I have a question.
All right, go for it.
From the start, you mentioned optimism rollup, that Arbitrum is built on optimism rollup. Doesn't that make Arbitrum an L3?
Sorry, I didn't say optimism rollup, optimistic rollup. Optimism is a different blockchain of its own that also uses optimistic rollup. Arbitrum is another blockchain that also uses optimistic rollup. Hello, are you still there? Yeah.
Yeah, thank you. Another
Yeah.
question.
All right, shoot.
Another question.
Yeah, go ahead.
Arbitrum has a virtual machine that helps compile other programming language.
Yeah, the programming
Like,
language. Okay, continue. Finish your question.
Doesn't that introduce like a vulnerability threat on security? How did they tackle that challenge? Like, how did they tackle the challenge of security in providing their own virtual machine that can compile your code before and run it?
Okay, so this is what happened, right? What the stylus does is, the Ethereum virtual machine, normal level, compiles this thing. You write a semantic code, it compiles down to bytecode, and it gets executed on the Ethereum virtual machine. Now, what Stylus does is it's giving people a room to use other programming languages to build on Arbitrum, and this will also run the same way Solidity runs on EVM. And now, the programming languages that are supported are programming languages that compile down to WebAssembly, which is Rust, C, and C++. So they built that WebAssembly virtual machine that handles this. So when it comes to how they tackle security, I think this is a question that someone from the Arbitrum core can answer, because I wasn't part of the core Arbitrum architecture, so I can't really tell how they were able to handle certain constraints and all of that. But I'm sure, it has been battle tested for it to come out, just like you, a developer, where you finish writing your smart contract. Before you take it to mainnet, you deploy on testnet first, write unit testing, give it to auditors to audit and ensure that there are no vulnerabilities. So I'm sure it has been battle tested for it to come out live. Yeah. So that's it.
Okay, thank you.
You're welcome.
Thank you.
Yeah, I have a question.
All right, shoot.
Okay, but I think this is more directed towards the hackathon itself. So like so the question goes those. Depending on the projects that we can build on the hackathon, are there any requirements, or would I say guidelines on the kind of project you can build for the hackathon?
Okay, so I think that's for me to answer. We would release a more structured requirement list and instruction for the hackathon latest, maybe tomorrow, next tomorrow, before the hackathon actually starts. So don't let me say anything and then I'll go change it later. I'm still putting those things together. So just expect it could be in the mail, a tweet or something. You will see a more detailed requirement. So thank you.
Oh, okay. So is the hackathon on the same day as the event?
Yes, it's a real life hackathon. The event is on 24th of Saturday, and that same day we're having the hackathon.
Wow. Is it like 24 hours or 2 hours?
It's a mini hack. So killing a hackathon itself, it's not. It's a mini hack. It's also looking at speed, how much you can put things together, how quick are you to execute, are you ideas. So it's a mini hack, not 24 hours. In a space of time, have the idea, build it, ship it, make something that is probably usable or something that is an interesting use case. Yeah.
Okay.
Thank you.
I have a question.
So, all right.
So for the faucets, what about people that doesn't have 0.18 to be able to get faucets?
Personally, I was able to get the faucet yesterday. I don't know, maybe if there's a provision for faucet to be given to people, but I haven't checked. I didn't check order. So let me bring this over here just quickly. So you see, there are 1, 2, 3 guys. I didn't check the first and the last one. I only used Alchemy because I have my way around it, and I have 0.0018 to get it. So I think you can check out QuickNode and Sepolia. if maybe you can get faucet from any of these two. If that doesn't work, I'm sure you are in the Web3 Afrika Discord, so you can maybe say something and maybe they'll find a way around it.
Yeah, that also. Thank you for asking that question, because that is something that I feel I would not have realized. It's getting increasingly difficult to get test tokens to the things. Yeah, the rules are getting tricky nowadays. So perhaps maybe we can do like if you need test tokens, we can, or maybe on that day we can share to people that need. So maybe we'll gather wallet addresses and share. I think that is that would be a good way we can get. I think it's 0. What? How much do you think we need to like deploy for any deployment? At least
with 0.01, you're good. Like what I got from the faucet yesterday was 0. What I got was 0.1, and with 0.01 you're good. This is 0.09, so with 0.01 one should be able to deploy.
Okay, so I think it's an interesting thing to also account for. So I would maybe discuss with the team and maybe on that day. So how you get it before that day, I think you can do all this, but on that day we'll make sure at least we can have something ready just in case.
All right.
All right. Any other live questions? We have about 8 minutes more before we round up the first virtual session for the builders event. So in case you have something else to ask, and Cass, if you can do like a rounding up overview of what we discussed and everything, that would be nice.
Okay. All right. Okay. Let's just go through it. So to round up everything, like I said, Arbitrum is a layer 2 scaling protocol that is solving one of the major challenges of Ethereum, which is the scalability issue. And in the quest, there are two ways in which most of the layer 2 protocols that solve Ethereum problem, there are two approaches which they use. One is the ZK rollup, and the second is the optimistic rollup. And Arbitrum uses the optimistic rollup approach to solve this problem. And in doing so, optimistic rollup is like when they post transaction, they assume and they believe that the transaction is valid, it's not doesn't have any fault. And when it's posted, there's a dispute period of 7 days. That the last time I checked, 7 days. I don't know if that has changed, but there's a dispute period of 7 days where watchers can dispute a particular transaction and say this transaction is not valid, and they are going to provide a fraud proof to prove that the transaction is not valid. And if it's found not to be valid, it will be reverted, and the validator that posted the transaction will be slashed. Yeah, slashing is a common term used in proof of stake in the Ethereum ecosystem. Now, we looked at some of the tools and versions of Arbitrum, where we talked about Arbitrum 1, Arbitrum Nova, and Arbitrum Orbit. Arbitrum Orbit gives you the ability to build your own blockchains, which is like a layer 3 blockchain on Arbitrum. And one of the major focus of this workshop is the Arbitrum Stylus, which enables you to write smart contracts both in Solidity, Rust, C++, and C, and everything will work perfectly well on the Arbitrum Stylus VM. So the Arbitrum Stylus core is divided into two parts. It's like a multi-VM that encompasses of the EVM and also the WebAssembly VM, which is Wasizin VM. So the Wasizin VM is able to, when you write contracts with languages like Rust, C++, C, they compile down to WebAssembly and they are executed in the WebAssembly VM. Similarly, when you write with Solidity, it's executed in the EVM. And we're able to go through writing a smart contract and deploying it on Arbitrum chain. We wrote a smart contract with Solidity. We were able to add a network, which is also provided in this slide and also in the Arbitrum documentation. When you add a network to your wallet, you can connect your wallet and deploy any smart contract directly on the Arbitrum chain. And if you also write Rust, because if you go through the Arbitrum docs, you see, let me quickly show you that. You see how you can easily build with Rust. This is it. So with this, write a smart contract in Rust using Stylo. This is it. You can write with Rust, and it also run on Arbitrum and all of that. So that is like a quick rundown summary of what we did today, and yeah.
All right, Caleb, just a minute. Thank you so much, Cass. So this is the rundown of everything. Okay, we have more hands. Okay, let me have them come up instead, so I don't. And Wasiu, please unmute yourself if that's a question. Okay. All right. So thank you, Cass. Really insightful session. Hello, Wasiu,
Yeah,
are you saying
I can
something?
hear you.
Oh, okay. Okay,
Hello.
so that's
Can you hear?
hello. Yes,
Yeah.
yes, I can.
Okay, my question is thank you guys for the workshop. Thank you. It's very insightful. My question is, for those of us that are like front-end based devs in Web3, is this hackathon suitable for us?
So I don't think.
You get my question?
Yeah, can you hear me?
Yes, I can hear you.
I can hear you. I can hear you.
All right. So when building for hackathons, right? Writing only smart contract, your judges can't interact with your smart contract. So front-end developers need to be a front-end developer. There need to be a front-end that interacts with a smart contract. So if you're a front-end guy and you don't do Solidity, you can come up with a team that has a smart contract dev, and you write build your front-end to interact with a smart contract. So you guys can be a team and all of that. I don't know if that answers your question.
Yes. Sorry to add to that, Wasiu. Yeah, just like Cass mentioned, that's quite important to team up. And then because this is a mini hack, so we're opening it up to like 4-minute teams of like 3 maximum. So you can be the front end, and then you have like the back end developer build the smart contracts, and you'll be good. Maybe the last person can be the designer, or the last person can be the project manager, maybe somebody that can help you just create slide while you guys are working. Because it's a build-a-thon and it's open between 3 to 4 hours because it's a very mini hack. So think about it, think how fast you can execute something, think how fast you can build, delegate tasks in between yourself, and then be part of it. So that's what team. And if you choose to be a solo hacker, maybe anyone on this call, you are a front-end dev, you also know how to write smart contracts, it's fine. You can go ahead and build both front-end and back-end. We'll give you a very simple Google form to fill in to get all your details, the submission details that anybody can use to review that project. And then we just based on that because of time. I hope that answers your question.
Okay. Yes, you've answered my question. Thank you. Thank you.
All right. Okay, I see some questions here. I'll just run through them and then we call this a day, and I'll tell you what we're doing tomorrow. So where is the hackathon holding? The hackathon is happening at Go My Code. It's the same day as the main builders event. You can check the link I shared in the chat. That's where you can find more details about it. And if you've not registered and you're this call, somehow maybe from the Discord, to be a good time to also join the hackathon, the mini hack. All right. So another question is, would you be building on Arbitrum Bolt too? See, at this point, just the idea is build with Arbitrum tech, deploy on Arbitrum. So however you want to do it, whatever you want to do, just make sure that you are using or interacting with Arbitrum in some form. So that's just the general thing. That's just the I said I will drop more details about the requirements, but just to answer that, and how many person per team? I think the Web3 Afrika person just answered that. All right. So thank you so much, guys. For tomorrow, we'll be having another speaker, Aprit, and we'll be doing something more hands-on. And more importantly, it's going to be a build use case. We're going to build something that we actually work. I think the speaker is coming to do something on building something with Stylus and using Telegram. So a mini app that you can launch on Telegram that interacts with Stylus or do things on Stylus. So I'm really excited for that tomorrow session too. So if you came for today's zone and you enjoyed it, you definitely don't want to also miss out tomorrow's zone, and bring your team members if you're in the team or you are intending to act with somebody. To be nice to have them tomorrow. All right. So thank you guys. Thank you, Cass. Really, really happy that we're able to get it started. And with that being said, I really hope to see everybody again tomorrow. My name is Cora, and this has been fun. See you guys same time tomorrow, and enjoy the rest of your day. Bye.
Bye, everyone.